next few days. All right. So the main objective of the presentation is to understand the concept, and to be able to formulate a study question and interrogate the literature. You need to know how to look up the literature. Probably the best way to do it is with exercises, and that's why the tutorials are there. We're going to try to do that during the tutorials. But these are some of the objectives during the whole course and how to do it. But also, you need to get familiar with reading the methods section within a paper. We need to be comfortable not skipping methods and going to results and conclusions. Whenever we have a paper, we need to be comfortable with the language people are using to describe the methods of study. And also, eventually this will keep you, or this will allow you to stay updated with the quick advances in the literature and new developments in variable medical fields. I'm not asking you a lot, because we have 3 days. We can cover all of these in 3 days. Hopefully we will do. But I'm asking you only one thing, is stay calm. Don't get panicked. You're going to be introduced to a lot of literature. If you don't understand what I'm saying today or in this lecture, you will be covering this later on during the course of the days. So that's what we need to agree. Okay. Let's move on and start the during the next few days. All right. So the main objective of the presentation is to understand the concept, and to be able to formulate a study question and interrogate the literature. You need to know how to look up the literature. Probably the best way to do it is with exercises, and that's why the tutorials are there. We're going to try to do that during the tutorials. But these are some of the objectives during the whole course and how to do it. But also, you need to get familiar with reading the methods section within a paper. We need to be comfortable not skipping methods and going to results and conclusions. Whenever we have a paper, we need to be comfortable with the language people are using to describe the methods of study. And also, eventually this will keep you, or this will allow you to stay updated with the quick advances in the literature and new developments in variable medical fields. I'm not asking you a lot, because we have 3 days. We can cover all of these in 3 days. Hopefully we will do. But I'm asking you only one thing, is stay calm. Don't get panicked. You're going to be introduced to a lot of literature. If you don't understand what I'm saying today or in this lecture, you will be covering this later on during the course of the days. So that's what we need to agree. Okay. Let's move on and start the who is in here who can or read a paper or a study in the room? So almost everyone had read a study, and you probably question should be answered. Right? After that, you really need to identify the participants who are the people involved in the study, whether they're patients or healthy individuals, whether they receive the intervention or the exposure, or whether they are the what we call as controls, those are the ones who are free from exposure or free from the intervention. So you need to set up some, or the researcher needs to set up some criteria on selecting those. So these are the who, and how to select them is the sampling design. You need to know how to select these participants. After participants, you have what we refer to as measurements or variables. And we'll get to that in a few slides ahead. But we have something called predictor. We have something called outcome. And there is something that could be a little bit confusing. It's called confounder or confounding factors. So those confounders are somehow related to the predictor and outcome. But we'll get to that in a few slides. Eventually, you need to know how the researcher, as a clinician, you need to know how the researcher has handled the study by setting up a sample, so how large, and setting up some sort of statistical methods of answering that sample. So they've got a hypothesis, they have a sample size, and they have an analytic approach. Okay. So let's start with the research question, and I usually ask myself, this is an Arabic saying, in France, in Arabic we say, خير يا طير. خير يا طير means, so what? So what? If you read a question, you really need to know the uncertainties and the objectives of behind answering the question. There might be a valid question, but that question is not worth the investment in answering it. So you really have to pass this stage, and that critical stage is, so what about answering the question? So you need to, first of all, when you interrogate, when you appraise an article, you need to convince yourself first, or the authors need to convince you first that their question is important to you, to your patients. That's very important. So that's probably the critical step. If it passes so what stage, then you need to proceed with reading the paper. But how do you know that this خير يا طير is true, or it's an important question? There's something or a concept called final. I don't know if you heard of final, but let's try to answer this together and make it a little bit more interactive and throwing some positive energy in the room. So this is an acronym of how to identify important questions, or so what, answering so what step, by seeing whether the question meets the final criteria. So if I tell you that F stands for feasibility, feasible. So the question is feasible. What do you think I stands for? Not everyone at the same time. What? I stands for interesting. The verb, So interesting, right? M stands for question, important question. You want to know if the question is important, or you can apply it. So N stands for new. I heard new, the verb, novel, something new, some new information. With this question add new information to the literature. E stands for ethical, the verb, ethical. And R probably is the most important thing for you as a clinician. R stands for, it's relative, relevance, the verb. Okay, so feasible, interesting, novel, ethical, and relevant. So if you pass this stage, we're good so far. We can proceed with reading the paper. Paper makes sense or passes the so what stage. The concept PICO, I'm not going to spend much time on it because we're going to spend much time on it in the small group tutorial, but you really, if you need to get something out of this whole 3-day workshop, is to get familiar with the concept of a PICO question. PICO stands for population or a problem, some people say. I stands for intervention. Some other people refer to it as exposure, E, so sometimes they replace the I with an E, exposure, so it's called PICO. C is usually for comparison or controls, and O is for outcomes, what the outcome came out from exposing or having an intervention applied for a population compared to the controls. As simple as that. Okay? There are some people who actually have taken this one step further and added the delta T, and T stands for time. So over how long? So you got population, intervention, comparison, outcome, over how long? Over the duration of time. So this is how the PICO is applied. So for every question has to be somehow a narrowed question. So you need to make it more of a focused question. You need to identify what population the study is dealing with, what sort of intervention or exposure, what sort are they comparing this to healthy people, are they comparing this to similar people, controls? What are they looking for in terms of outcomes? And are these outcomes important to the patients? Are they important to the investigator? Are they important to the academic staff? So is it an academic outcome versus a clinical outcome? And over how long time? As simple as that. If you want to get something out of this workshop, it's how to formulate a question in a PICO format. Okay? So far so good? Any questions? Again, feel free to get yourself some coffee in the back of the room if you need to. See some eyes drool, some drooping eyes that you can see. So and make sure that everyone is on the same page. Let me give you an example, and that's how I probably will get some energy. Just going to throw a question. Should people eat fish? Should we advertise for eating more fish? Because nutrition are advertising for so many things and advertising against so many things. You have no idea whether these things are actually proven by evidence. And social media is not yet helping as well. There are people, apparently there are people expert in everything in social media, unfortunately. But let me ask this simple question. Should people eat more fish? This might be a good question. However, it's a very broad question. It's a very vague question. It's not a very specific question. You don't know what kind of people, what kind of fish, what's the ingredients of the fish, how much of fish, what are you looking for. All of these things should be answered as well. So this does not meet PICO format. It's a very generic question. You need to be more specific when you ask for a strong or a focused question. And I'm just going to give you a few examples that makes it a little bit more narrowed of a question. So if you ask, how often do Kuwaitis eat fish? So you're asking about frequency, you're asking about certain population. So at least you're narrowing your question compared to the top question. Okay? If you're asking, does eating fish lower the risk of cardiovascular diseases? So you're a little bit more specific about the outcomes because you have no idea what. Okay, so I'm advertising that fish is healthy food, but in what terms? What are you looking for? If fish oil is equivalent to dietary fish, so you're comparing an intervention versus another comparison. So you're comparing it versus eating some other formula of fish or versus eating no fish. So it could be, this is another way of narrowing the question. Or is there a risk of mercury toxicity with fish? And this is a crucially important thing that we have to look at, is whenever an intervention is advertised for, you also at the same time have to make sure that that intervention safety profile is being looked at as well, whether adverse effect events are looked at as well. I'm just going to somehow switch over to types of studies. And it's as simple as this diagram. We've got three main types of studies. One of them is diagnostic tests. We're looking at diagnosis. One of them is where the investigator has a passive role, not giving an intervention, but watching what people are doing, how people are doing while getting exposed to something. And the other one, where the researcher has an active role, or the investigator has an active role, and that's called a clinical trial. Clinical trial can be randomized and non-randomized fashion. We'll talk more about that in the tutorial, inshallah. But the observation, we have the cross-sectional studies, and we have the cohort studies. Cohorts could be retrospective and prospective. But really, when it gets down to what are the main types of studies, these are the main types of studies. We've got a diagnostic test study, and we have a clinical trial, and we have, I should say, non-clinical trial or observational study, where the investigator has a passive. I'm just going to take that even more, and also and focus on these two, and give you a few examples or applications also to fish intake, and try to apply it in this very simplified fashion. So let's start with observational studies, and probably with cohort studies. Anyone who knows what the translation of a cohort, or what's the English translation of a cohort, the word cohort? Cohort is marching army. It's a marching part of the army. Okay? So that's the original term of a cohort. Cohort is a marching part of an army. So you can imagine in these videos when we watch them, marching one group moving, and that's probably self-explanatory for a cohort study. So there is a sample of patients, and you take the measurements at certain points, and you follow that cohort of patients over time. So that marching army is moving in front of you, and you're watching what happens to that marching army over time. You measure the exposure, and you're also measuring the outcome. So let me make it a little bit more in a diagram. So let's assume this is the whole population of the world, and we're assessing one risk factor. And as you probably know, most of the risk factors, they have some sort of continuous pattern. But the forces of the world of medicine are usually, they really would love to see some sort of threshold or a line that's drawn. So if let's say that we are measuring cholesterol, okay? And we say that anyone above the level of, this is all made of 5, anyone who's above the level 5 has a risk factor. So this is what gets done in the literature. You draw a line, say, okay, anyone who is above this line has a risk factor, anyone who's below this line has no risk factor, and this is how we usually do it. Okay, risk factor present, or risk factor absent. Okay, and this is at the present time. So you get a sample, and that sample is a mixture of people with risk factor and people without risk factor. and you watch that sample over time and see what happens in the future, hoping, by hypothesis, that those people with the risk factor will have, not hoping, but hoping that your hypothesis is right, those people with the risk factor will have disease more than those who don't have the disease. And those people who have no risk factor will have no disease more than those people that will have disease. As simple as that. That's cohort study. Start at some point, you follow up with time, you measure the risk factor, and then you look for the outcome, which is the disease at the end. Okay? This style of study, or this type of study, has its own advantages. It's a strong way to assess the incidence. And do we know what incidence means? Incidence. Number of new cases, excellent. Number of new cases. Those numbers were picked during the follow-up. So you watch people, those people are free of disease, but you have a risk factor. You think that risk factor leads to that disease. With time, you see some people developing that disease. And this is the incidence, picking up new cases while out of the whole sample that you get, especially those with the risk factor. It's very helpful to tell you potential causes, because that's how hypotheses happen. You hypothesize that risk factor will lead to that disease, and you watch people developing that disease with the hypothesized risk factor. It also establishes time sequence. It tells you, for example, if you start smoking today, you'll develop, let's say, lung cancer in 15 years. All made up, not true. But that's what I'm saying. It may give you some sort of time sequence. And also prevents the influence of existing outcome. This is very important because you don't start with someone with the disease, you start with someone without the disease. Okay? And you see whether they develop the disease as well. Because sometimes it's confusing, especially in cross-sectional study. You don't know whether it's what's the exact relationship between the risk factor and the outcome itself. But that style of studies have its own disadvantages as well, or weaknesses. That causal relationship that we were talking about is not true a causal relationship because you're not 100% sure, you cannot swear that there are no other things that was out of your hand that wasn't controlling the relationship between the risk factor and the disease. There might be something else. So you're not 100% sure about it. Confounder, we'll get in a second, is still there. Confounder is a measurement that is, or a variable that is related to the predictor and also related to the outcome. Can cause the outcome and can be linked to the predictor. It's expensive because you're following these people on time, over time, and usually you require a large sample, and following a large number of people is quite costly. And following people will not be free of dropouts, so people will start quitting recruitment. So that's one of the major risks, is that you will have loss of fellows. And cohort is not the best way to look for rare diseases, because let's say that a rare disease happens 1 in a million, it means that you need a cohort of 1 million people to pick up one case. And that's not practically extremely expensive. Okay? So these are the weaknesses of a cohort study. If we go back to our fish and tape example, in few words, cohort study is a group of people followed over time. And if you want to apply that cohort style over answering the fish and tape, you can ask people about how much, or you can measure how much people are eating in terms of fish at baseline, and then follow up this cohort to see the development of cardiovascular disease. Do you get? You're going to hear that word later. All right. We'll try to, from this table, we'll try to get examples on each of the types of studies that we're going to cover. Now I'm just going to switch over to cross-sectional studies. And in cross-sectional studies, it's as simple as running a survey, for example. Taking all measurements at the same time. Taking the information about the exposure and information of the outcome of the disease, both at the same time. So it describes the variables and their distribution pattern. Let's say that I wanna know how many diabetics are in this room. I'm just gonna run a quick question. So I'll have a sample of 60 people, and I'll say how many of you have diabetes. And let's say that I pick up, let's say, for example, 20. So 50% of the whole population have diabetes. This is as simple as that. That kind of distribution pattern we can get out of cross-sectional studies. It's very important also for decision makers. They rely on cross-sectional quite a bit, although we don't advertise for that. It examines the association between the variables, and we can add one variable with the survey that we ran inside the room. So how many people are diabetics? Say 30%. How many people exercises? Say 10%. And we'll say because there are 10% of people in a room of 6 only exercises because of low exerciser, there's a low percentage of exercisers, there's a high percentage of diabetes in Kuwait, for example. So as simple as that. So you take two measurements, exposure, that you think is protected against diabetes, you have the disease, and then you try to put a link between them. So there's an association between low exercise rate and high prevalence of diabetes by running a cross-sectional study. So prevalence is what? So the number of existing cases, excellent. So those who already have the disease, all right? But you're not following them, they're not new cases. You're not following them over time. You just ask them, are you diabetic or not? They say yes, that's prevalent. Okay, so in a diagram fashion, same all population, and you're drawing a threshold line between those who have risk factors and those who don't have risk factors. And then at the same time, you're not going to follow up anywhere. This circle is not going anywhere. It's going to stay the same. At the same time, you're going to ask them, so they have the risk factor. You're also going to ask them, they have the disease. And by hypothesis, this is what people are looking forward to. Those who have a risk factor and the disease are more than those who have the risk factor and healthy, compared to those who don't have the risk factor and healthy should be more than those who don't have the risk factor and have the disease. Okay? Again? لا والله مش عارف كده. Okay, so it's fast information. Just run a survey right now, get information, get association. Inexpensive, it's really cheap to have these kinds of answers. And there's obviously no loss of follow-up because I'm just going to run the survey once. And that once you're done with the survey, hasta la vista, khalas, I have the information. But that business is pretty risky. Why? It's extremely difficult to make that link of a causal relationship or even the association, in my opinion. But that cause and effect relationship is extremely difficult to come up with. So people say, let's say, sleep more than 10 hours, because this is healthy. Why is it healthy? Because those who sleep more than 10 hours, they don't have diabetes. And they get that information from a closed room where they run a survey like that, the one that we described, exercise and diabetes, for example. And they make that link between number of hours. I'm using made-up examples, so don't take that for granted. So increasing number of hours of sleep and the risk of diabetes and the prevalence of diabetes. And then they make it even more, stronger statements by saying that if you sleep more, your risk of diabetes will go down. And that's not true based on cross-sectional studies. This is risky business. And it's also impractical for rare disease, because if we have a rare disease and we sample, let's say, 1 million people, we're going to pick up one. If that rare disease prevalence is 1 in a million. So that's also impractical for rare diseases. And you also have probably no information about prognosis. You don't know what's going to happen in the future. You're not following up people over time. Also, about history, there is limited information about what happened in the past. So people may forget what they've done in the past. You're simply interviewing them. So, in brief, cross-sectional studies, group examined at one point. Simple as that. Okay. When I apply that, or when I use that to run a study over fish intake, can take a group, a sample of people, interview them, and survey them about both fish intake and cardiovascular diseases, and try to make that association. Sample a lot of people and see they have high fish intake and lower prevalence of cardiovascular diseases, and try to make the association that increasing fish intake will lower the risk of cardiovascular diseases. Risky business. Okay? Good. So I'm just going to have this quick comparison between cohort and cross-sectional. We know that cohort gives us incidence, while cross-sectional gives us prevalence. So I give you two words, and by definition, among those with a risk factor, we say those who have the disease versus those who get the disease. So which one would be the cohort study? Have the disease or get the disease? Get the disease. And for prevalence, have the disease. Yes, should probably go home now. Good. So case control might be a little bit confusing. But I think we can also, with a diagram, can start it better. With case control studies, you start with the outcome. You start with the disease, in our case. You start with the outcome. And try to investigate the causes of that disease, or that outcome. So obviously, you can use it for rare diseases, because you can collect the 10 or 20 people that you see in your clinic, and then ask them about the past, about exposure, or what happened in the past. And try to make a link between their existing disease and what they've been exposed to in the past. Good? Alright, so you can use the case series equation and identify risk factors, and you should always, or researchers should always, compare those group patients, after asking them about their previous exposure, compare them with a group of healthy people disease-free, these diseases of interest. Get people with cystic thalassemia, and you get people with no thalassemia, and you study the exposure of the past. In the past, what happened in the past between them, the diseased people, or the disease sample, and the reference group or the reference sample. So you go back in time. So you start with the disease, now with the disease, and you go back in time. And let's get into the diagram now. So you start with two populations, and you get a sample from a population with the disease. Let's say that you have a pool of, let's say, 1,000 patients, for example, or 100 patients. And you try to pick 10 out of them, and you compare that with a pool of healthy population, take a sample out of them. I made the grading a little bit different, assuming that the risk factor is different between them. The risk factor is higher in the people with the disease. Anyway, taking cases or a sample of cases with the disease from the larger population and taking a sample of patients without the disease from the larger population, and then, this is at present, you're going to go back, right? You're going to go back, you're going to ask them whether the cases had risk factors. We're going to test them whether they have these risk factors or not. And the hypothesis, investigators hope that those cases will have more of them will have risk factors compared to those without the risk factors, compared to the controls. So they're hoping the controls will have less risk factors than those of the controls with the risk factor. Good? Okay? DA? Okay. It's fast and it's expensive to do that. It is fast. You can get immediate answers. And you can get so much information because you're starting with the pool of patients. You can ask them as much as you want about the past. And also, as we said, and this is probably some sort of an exam question, it's the preferred way to study rare diseases, case control, because you start with the disease. You don't look for the disease. You look for the exposure, or what's being done or what's being considered as a risk factor. And it's very good for delayed diseases. If we say that a disease needs 20 or 30 years to develop, we don't follow up someone who's getting exposed with a hypothesized risk factor for 20 years to see if they develop the disease or not. You actually pick up those with the disease and then you ask them about the past. So that's, you can see that this is very practical and much less expensive and not so much time consuming. It saves a lot of time. We said it's fast. So it's very good for delayed diseases. On the other hand, some risky business as well is going on with case control. There is a huge risk, not only a risk, huge risk missing data. Because you can ask about so much, but you can get so much as well. Because you can't control what happened in the past. What happened in the past, it happened in the past. Let's say that you want to look for a urine test for someone with a rare bone disease. Not everyone who have that rare bone disease will have that urine test available done in the past. So you want to ask, there is a huge risk of missing data. You can't get prevalence or incidence because you're not picking up the cases. You're actually starting with the cases. So all of your cases will have the disease. These two terms don't apply. And you can only study one outcome, which is the disease of interest. This is probably the most important point of the weaknesses of case control studies. Recall bias. Recall bias, and probably we'll talk about this later on as well. For recall bias, you can ask people whether they had or they were eating healthy food. You're not 100% sure if they can recall that information or not adequately. So the adequacy of the recalling information, especially if you ask them about history. I'm just going to go back to that diagram, you're making a huge assumption, or the researchers are making a huge assumption that these two populations are separate from each other, which is not true, because we've got only one population on Earth. So who said that there is a line drawn between these two populations? There might be lots of interactions, similarities between these two populations. So this is another source of bias, some word that we're going to get familiar with later on today and also over the course. And so that is the risky business with case control studies. Going back to our table, in brief, two groups selected based on the presence or absence of outcome. This is the case control study. Start with the outcome, going back to see what the exposure was. When I apply it to our fish intake, so comparing patients with cardiovascular disease versus those who don't have cardiovascular disease about fish intake. Simple as that. You start with the outcome, cardiovascular disease, people with the disease, and you compare them with the people without the disease by asking both groups about history of fish intake. Did you eat fish or not? Hoping that those with cardiovascular disease have eaten less fish. You get my point? This is how we apply this in that format. Now we're going to end up with a randomized controlled trial, something that we're going to spend so much time as well, because I strongly believe, based on my tutors and mentors, that this is the only way to answer questions. Not applicable for every scenario, but probably the best way to answer a question. It's basically picking up a sample. That sample will be randomized into people who are going to be receiving an intervention versus people who are not going to receive anything, or going to receive something as a comparison, something. They're comparing an intervention to a comparator, hoping that those who receive the intervention will have less deleterious outcome, less bad outcome, they'll be healthier more than those who don't receive or will not receive that intervention of interest. As simple as that. That's RCT. Okay? It's simply, there's an active role of the investigator. If you remember in that diagram, there's an active role. Investigator applies the intervention. And randomization is a magical word. Randomization is a magical word. It's probably the best way, but that style of studies is the best way to demonstrate causalities. And the secret is by randomization. Why? Because it eliminates confounding. Give me two more slides and I'll get to confounding. And blinding, not knowing if you had received the intervention or not knowing if the patient had received the intervention or not, makes the bias will have much less effect. And also co-intervention will have less effect by applying blinding. We'll cover that in the tutorials, definitely. But that kind of business, I can tell you, it's not a joke. It's highly expensive. You're investigating, people monitoring, people giving the intervention. You really have to have another question. And you cannot swear for sure that there are no potential harms of that intervention. And that's why everyone has to look at for the safety profile for an intervention. And as I said, it's not applicable for every research question. You can't randomize people towards smoking and non-smoking, for example. You can't blind people from having no surgery versus surgery. And people who know they have received if they have undergone surgery or not. Right? So it's not applicable for every research question. But if we go to our diagram or to our table, we we have two groups, in brief, two groups created randomly for an intervention, and usually along with blinding. So if we are going to apply it to fish intake, we have random assignments of fish oil versus no fish oil. Some people will receive fish oil, some people will receive no fish oil. Just going to go back to this diagram. Fish randomized to fish oil versus no fish oil, or another gradient, or placebo. Hoping that those who will get fish oil will have less disease than those who don't get fish oil. Okay? Now we can talk a little bit of details of what RCTs or an intervention study will be made of, probably setting up the scene for our first tutorial. But the entry criteria, inclusion and exclusion criteria, usually found in where in a study? Methods, where exactly? Where do they usually demonstrate to patients in a study? Inclusion, exclusion, where do they demonstrate? The results, methods, results. So in method, they will talk about inclusion and exclusion criteria. And whenever they recruit patients, they're going to demonstrate to you their characteristics. So their baseline characteristics will be demonstrated where? Table 1, excellent. So in table 1, we usually refer to the table. And when you say table 1, it means baseline characteristics of patients. Okay? But it's very important to know how the sample size is calculated. And how do you think the sample size is calculated? Usually it requires a biostatistician and clinician, right? But how do you think, who decides that 200 versus 2,000 versus 20,000 is a good number for sample size for a study? I'm just going to collect what you guys say and then I'll throw it back at you. So, how do you think sample size is decided on? So I'm giving you some hints in here. A clinician has to have a say, and a biostatistician has to have a say. So there's an equation, excellent. There's an equation in it, and that equation would have type 1 error, type 2 error, or power, right? And what else? Someone said prevalence. Someone said, well, you need the treatment effect. You need the hypothesized treatment effect. You say, for example, I give you that intervention, it lowers blood cholesterol by 10%. So you need that figure, that treatment effect, to be put in that equation. So that's how the clinician needs to answer a question to the biostatistician. He's going to take that clinical information, factor it in the sample size calculation equation, also have the power and type 1 error, everything else, and then come up with 200 figure, or 2,000 figure, or 20,000 figure. So divide them into 100, randomize into 100 intervention versus 100 control. So this is how the sample size cut, as simple as that. Okay? It's very important to know that. So it's really based on estimated treatment effect. And as you said, predictors are the exposure, or what happens first in terms of biological causality grounds, and outcomes is what happens after. But confounders, I promise we can go back, we can describe that. Confounders are another predictor that is somehow linked to the predictor of interest that can also lead to the outcome. So let's take that. Let's take Kuwaiti participants. They eat more fish oil they will have less disease. But maybe those who eat more fish oil will have more or higher income. They're richer people. Okay? And richer people among Kuwaitis, I'm not saying Kuwaitis are rich. So those with higher income among Kuwaitis will have less cardiovascular diseases because they exercise more, because they eat healthier, more expensive, healthier food. And Kuwait's the opposite. So more, the richer, they it's the other way around. But yeah, maybe eating fish oil is linked somehow, being with a high socioeconomic status, being healthier in lifestyle, exercising more, eating healthier food, etc., and having lower cardiovascular disease. The textbook example, and probably we're going to cover that tomorrow, is any participants drinking coffee, more cardiovascular disease, right? But the explanation is that those who drink more coffee will do what? Will smoke more, right? Yasmin is going to tell us tomorrow about that, inshallah. But so the confounder in that equation would be smoking, and coffee was the sort of false predictor. That relationship is usually eliminated, crossed out by randomization. Because if you have a confounder, that confounder will be randomized into two groups. So you have a fair play. Even if coffee is not truly causing that disease, but smoking will be randomized into two groups. The only difference between the two groups would be the predictor. One of them will have coffee, one group will have coffee, one group will not have coffee. If you think that smoking is related, smoking will be distributed equally between the two groups. Okay? Confusing? Good so far? Okay, good. And what kind of interventions, since we're talking about that, it's really the most important step. It's about design issues. You need to know how much, how frequent, the interventions, etc. And there are some other issues like co-intervention. Is there anything else that's being delivered to one group other than the other group? That's very important to look at. And the intervention can be active, giving something, or withdrawing something. For example, smoking cessation, pharmacological or non-pharmacological. For example, diet, exercise, etc. And then you choose the researcher will choose a control, and it should be from the same population because you need a fair game between the two populations. And we'll talk about that in tutorials, inshallah. And preferably not, or to avoid not giving them anything. Confusing statement, three negative. Okay, so preferably that people will receive placebo. Okay? You give them something, but they don't know if this is beneficial or not. So that's the placebo. You take out that placebo psychological effect out of their mind. If you give them nothing, they'll say, "Well, I'm getting nothing. So I'm not getting better because I'm not getting anything." But if you give them placebo, that placebo effect will be gone. So you're really studying whether they are benefiting from the intervention or not. And as we said, randomization will distribute that any co-intervention between the two groups. And what kind of outcome people will be studying? Usually a single outcome study is preferred. People are starting to look at so many things, going to be very confusing, going to be extremely large study, it's going to be hard to take conclusions from. And better to have a clinical outcome more than not that important, not that clinical outcome. And surrogate outcomes is probably a term that you're going to come across when you read the literature, but surrogate outcome is somewhere in between. If you want to study fracture, some people, instead of studying a fracture, will study what? Bone mineral density, right? They're going to look for bone density. And that bone density, if it's low, they correlate that with risk of fractures. They look at cholesterol level, for example, and replace the incidence of cardiovascular disease with cholesterol level. I tell you that if you take that medicine, it will reduce your cholesterol level, so eventually your risk of getting a cardiovascular disease is less. This business, this conclusion, making assumptions, these assumptions are also might be also tricky. So also be careful with that, and always look at the adverse events. Okay, for the physiology, it's going to be very quick. Yeah, physiology is basically by drawing conclusion. There are two types of conclusions, and this is what we're going to cover over the next 3 days. Two types of conclusions are what we refer to as inferences. There is an internal inference or conclusion, which is the truth within the study, and there's an external one, which is generalizability, taking that truth from the study and applying it on the population. And those conclusions can also have risk of bias when the study is not conducted very well, or generalizability issues. So in a diagram fashion, if we assume that a researcher is conducting the study, they usually start with the design and implementation, starting with a research question, then do what? Then have the study plan, design the study, and then do what? Then having the actual study, implementing the study, alright? And then going backward within that design, having finding in the study, that findings in the study will have, you have to make conclusions to believe the study. That's what you do in here by reading the paper. And by having truth in the study, you're trying to make the conclusion of applying the truth of the study into the truth within the universe. So this is how we draw conclusions. At this level, you have the internal conclusions or risk of bias. At this level, you have the generalizability or applicability issues between the two, at these two stages. And that's what we're going to cover in the tutorials. Okay, I'm just going to throw a couple of, it's 9:55, but I'm going to close with some life-to-life examples. So this is an old slide I usually use in these presentations, and I try to challenge the audience with saying that we are actually doing critical appraisal every day. We're not missing that, doing that every day. And 2-3 years ago, I think, actually not longer than that, I've seen that Twitter survey, and allow me to describe that in English. It asks about the number one singer in Kuwait, and it gives 3 options. Probably the 4th option is others, but let's ignore the 4th option. But they're running a survey between 3 famous singers in Kuwait, and they're asking the audience, which do you think is number one singer in Kuwait? I don't need you to tell me what your opinion is, because that's not the important issue. But the important issue from you is to tell me which one do you think is going to win first prize, or is going to be considered as, will be voted as the number one singer. Number 1 is Awad Dukhi. Those who think that Awad Dukhi will be voted as the best singer in Kuwait, show me your hand. Not your opinion. What I'm saying is, I need you to tell me if you think this poll, people, when they evaluate which one won this poll. So Awad Dukhi, which one thinks that Awad Dukhi will win the survey? Probably one out of 60. Abdul Karim Abdul Qadir, one or 2 people. Abdullah Rwashid. Okay. not because you love Abdullah Rashid, but you're telling me that people will vote for Abdullah Rashid, right? Why do you think that is? Why do you think Abdullah Rashid will win this vote? Excellent. People saying generation Twitter, people are voting. This is directed to the younger generation, people comfortable with smartphones. So there is referral bias. There is also something else. When was the last time you heard our even if you love it, even if I love our I haven't heard it for a while. They're not playing that for a while. So what I'm recollecting right now is the most recent thing, which is the recall bias. So we have referral bias. The target audience within that poll, you know for sure that they're going to vote for Abdullah Rashid, and if you add someone else that is more popular among the younger population, they're going to vote for that as well. And people don't recall that information